Which of the following cannot be a probability? -1 can't, because you can't have negative. Number 2, the probability Lewis passes is 0.47. Find the probability that he will fail. The opposite, you subtract it from 1, because 1 means the whole, like 100%. Number 3, there are 12 crimes total. And we have 4, 5, and 3. Okay, 4 larceny, 5 motor vehicle, 3 robberies. What is the probability that one of the crimes is motor vehicle theft? Okay, it said there were 4 larceny, 5 motor vehicle, 3 robberies. The probability that it was motor vehicle, there were 5 motor vehicle crimes and 12 total. So the probability is 5 out of 12. Okay, number 4, we have a table. Okay, I'm not going to write the whole thing. Okay, we have gender, men and women. And then we have our totals. Okay. And then we have non-drinker, regular, and heavy. Okay. The total that we need, it says, what's the probability that somebody is regular or a heavy drinker? Okay, so that means we need our totals for each of these. Okay, and 392 is the total for all of them. Okay, regular or heavy drinker. So we're going to do regular plus heavy. Okay, or you add out of the total. So that is 59 plus 11. Okay, and you divide that, and you divide it on your calculator, and your answer is the division, the decimal that goes with the division. Okay, there were 59 regulars plus 11 heavy drinkers. That's 70 total. When we have or, we add. Okay, you add probabilities when it has or. There's nothing that overlaps because you're either one of those 3 categories, non, regular, or heavy. Okay, number 5, using the same table. Okay, so we have men, women, total. We have non, regular, heavy, and total. Okay, it says, what's the probability if you choose a person, that person is a man or a non-drinker? Okay, so we need all of our things that go with men. 187 men. Non-drinker, we need the rest of that. And we need the total number of people. Okay, 405. Okay, what's the probability man or non-drinker? Okay, so we have 322 men plus 322 men plus 187. No, that's sorry, let me start over. Okay. What's the probability you choose a man? There's 187 men. Okay. 187 men. Or a non-drinker. There's 322 non-drinkers. Or we use plus. Okay. However, these 135 men got counted as a non-drinker and also as a man. So that means we need to subtract 135, and there's 405 total. Okay, so we're going to add the top, okay, plus, and then minus 187 plus 322 minus 135 over 405. And when you divide that, you get 0.923. Okay, on this one, your decimal is your answer. Okay, there's a 60% chance that a mother gives this gene to her children. She has 3 children. So what's the probability that the first one and the second one and the third one all get? Okay. The probability of passing the gene, 60% is 0.6. Okay. So we're doing the probability that 1 and the probability that number 2 and the probability that number 3 all get it. Okay, the probability of each one is 0.6, and is when you multiply. So that's 0.6 raised to the third power, and that is 0.216. Number 7, there's 27 chocolates total. 3 of them have nuts, 9 of them have caramel, and 15 are solid chocolate. Okay, and it asks for the probability. Okay, you pick one, eat it, and pick a second one. Okay, so what's the probability that you pick one and it's solid? Well, there's 15 out of 27 that are solid. Okay, the chance that they're both solid means number 1 is solid and number 2. Okay, our first one and our second are both solid. Okay, so that's why we're going to be multiplying. Now, the first one, we're assuming that it was solid because we're finding the probability that they both happened. Okay, so this is no longer 15 solid, now it's 14 because we ate the first one. This is no longer 27, it's 26. Okay, the first one that we ate was solid, so now there's only 14 solids and 26 in all. Okay, now just use your calculator to multiply that. Okay, and then reduce it using your fraction decimal button, and you'll get 35 over 117. Okay, just multiply this stuff right here in your calculator. Okay, be sure you put in those parentheses, and then you'll get a decimal, and we use our F arrow D button on the calculator to get our final answer. Okay, number 8, we have another genetic question. Okay, we have 2 parents that are giving some genes. Okay, capital B is for brown because it's dominant. Little b is for blue. Okay. And you always write the capital first if you also have a lowercase. Okay. The only way to have blue eyes is both of them are blue. Okay. Capital B stands for brown. Capital letters in genetic means the dominant trace. So if you have any capital letter, that means brown eyes. So the only way to have blue eyes is both of them are blue-eyed gene. Okay, so what's the probability that the child will have blue eyes? Only this 1 out of 4 right here. Okay, there's 4 total possibilities, but anything with a capital B, brown, that's dominant over blue. So only one of those has blue eyes. Okay, number 9, we've got 9 members. They're going to form a subcommittee of 3. Order doesn't matter because they're just on a subcommittee. Order doesn't matter with a combination. So you're going to do a combination of 9 choose 3, and that equals 84. Okay, just use your combinations that are in your calculator. Okay, on the last one, number 10, there's 11 members, but they're going to elect a chairperson, a secretary, and a treasurer. Okay, how many different candidates, how many different arrangements can that be? Order matters here because they're being put into specific positions. Like the first person's the chairperson, the second person's the secretary. When order matters, we use a permutation. Okay, there's 11 people, and we're choosing 3 positions. Okay, and same thing, use your calculator on to do the permutation. And that's the end of the lesson.